In this video lecture, we can see some of examples in static indeterminacy. The static indeterminacy we can able to define as U minus E. The static indeterminacy always count the number of restraints. The number of restraints. What is meant by restraints? The reactions and bending moments. The reactions and bending moment are the restraints. So the count of total number of reactions and available number of equations. So generally summation fx, summation fy and summation moment equal to 0, the three equations, available equation. In some case, if a member is subjected to purely perpendicular loading, there is no horizontal loading, it is subjected only by perpendicular loading, means we can eliminate some of forces in x direction equal to 0 because there is no horizontal load. So we need not take this equation into account. Then you can use the number of equilibrium equation as 2. And in portal frame and other type of structure, we should include all the three equations. In beam itself, if you have some inclined loading, then if you resolve this loading, it will become horizontal component as well as vertical component. Then you should use all the three equations. So the static indeterminacy means number of unknowns minus number of equilibrium equations. The number of unknown count is the number of restraint count, that is the number of reactions at the supports, and number of resisting moment at the support are the unknowns. So with this understanding, we are going to the example problems. The first problem on trusses. If you see this type of structure, it is definitely trusses. The trusses, if you consider U minus E, this will be derived in such a manner that a truss member is a axially loaded member. Either it can be a compression or it can be a tension with respect to the joint. So this member is subjected to compression because the force is towards the joint. So towards the joint. Some member subjected to tensile force towards the joint. So that member is called as tension member. So the forces are always through its axis of the member. Hence, there is no bending moment in the trusses. So the available equilibrium equations are summation of fx0 and summation of fy0 only. No need of considering summation of moment equal to 0 because each member is having axial loading force. So the axial deformation is neglected. There is no resisting moment in that case. Hence summation of fx, fy should be considered. So the equation derived in the basis of each joint is having two number of forces equilibrium, fx0, fy0. So 2 into number of joint minus 3. How it comes? For example, if you consider a very simple triangular truss, if you in the need of additional joint, you will have two additional members. So each joint will have two summation of fx, fy, two components, so 2j minus, we are going to deduct 3. 3 means the basic members 1, 2, 3. 1, 2, 3. So this joint is considered. So 2j is the property of having summation of fx0, fx and fy0. Hence it is 2j. Minus 3 means it is deducted from the basic number of elements 2 minus 3. So each additional joint require this type of equilibrium equations and unknowns. So this degree of external indeterminacy is U minus E, that is U means number of reactions minus equilibrium equations 3, and degree of internal indeterminacy is M minus 2j minus 3, M minus 2j minus 3. You can see this M minus 2j plus 3. What is this 3? The reactions. So M plus R minus 2j is the simple form of this equation. So if you add these two equations, M minus 2j plus 3 plus R minus 3, you will get M plus R minus 2j. That is the summation of external indeterminacy and internal indeterminacy. External indeterminacy is U minus E. Internal indeterminacy is M minus 2j minus 3. So from this we can able to declare whether the truss is stable, unstable or redundant. Okay. So if you sum up all the two equations, you will get the final equation. In the case of truss member, you can use this simple only one equation to find out overall static indeterminacy. Otherwise, you have to separate into external indeterminacy and internal indeterminacy. So static indeterminacy is M plus R minus 2j. You count all the members 1, 2, 3. So 3 members. The reactions plus R is 6. That is one vertical, one horizontal, one vertical, one horizontal, one vertical, one horizontal. So there are 6 number of reactions minus 2j. Minus 2 into 1, 2, 3, 4 joints. 4 joints, it is hidden inside this. So 4 joints. So in that way you calculate the static indeterminacy value. In this problem you count the number of members 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Reactions, it is a roller type. If it is mentioned here, it is a roller type. So this will have only one reactions. This support will have two reactions. So reactions 3, joints 1, 2, 3, 4, 5, 6, 7, 8, 9 joints. So number of members it is 15. So we can verify this 15 reactions 3 joints 9 joints. You apply this formula directly to get ds. Otherwise dse equal to u minus e, that is unknown minus r minus 3, dsi equal to m minus 2j minus 3. Number of members minus the redundant. Whether it is adequate members are present in the truss, that is the internal indeterminacy. So if you add these two, you will get m plus r minus 2j. So all the values are available. You calculate whether it is statically determinate. Next problem, in the similar way, you count the members 4, 5, 6, 7, 8, 9, 10, 11. Both are roller support. Only one vertical reaction is here, because the spacing between this can apply for the rollers. So 3 number of reactions, joints 1, 2, 3, 4, 5, 6, 7 joints, 3 reactions, number of members 11. Let me check. Okay. I will calculate m plus r minus 2j, and it is proved to be statically determinate. Additional problems, you can try this problem and we can verify in the classrooms. Next, for beams. Beams, It is DSE, it is common formula, U minus E or R minus E, both are same. U is otherwise called as the redundant R. U minus E as well as R minus E is the same. DSI, from this previous video lectures, we can able to understand static internal indeterminacy is 3C minus R dash, where C is the number of closed loops. It available only in case of frames. For such type of frames, if this is a closed loop, this one is a closed loop, this will create two closed loops. So you can apply 2 into 3. Minus R dash means R dash are the releases. In case of kinematic indeterminacy, I already told that the kinematic indeterminacy is the number of freedoms, number of releases, the count of number of releases. In that case, we will add this R dash. Here this R dash to be deducted because we want only the number of restraints. So 3C minus R dash. So summing up all the internal and external indeterminacy to get the final static indeterminacy value. So number of reactions here, one vertical, one horizontal, roller, so it is one vertical, roller, one vertical, here one horizontal, one vertical and one rotation. And it is an internal hinge present in a member. So this hinge separating into two members. So the releases R dash equal to M minus 1 is the formula. Two members are joined to the internal hinge. So one release can be applied to this problem. In the similar way, you can find the reactions. The roller is having only vertical reaction. It will move in the horizontal reaction. So there is no restraint in the horizontal direction. Otherwise, the simply supported condition will have two reaction, one vertical, one horizontal. So in this case, R dash, you consider two number of hinges are present. If you consider any one hinge, it is connected with two members. So R dash equal to M minus 1 for the first hinge, M minus 1, that is equal to 2 minus 1 equal to 1, and R2 dash for the second hinge, it is connected to the two members, 2 minus 1 equal to 1. So total R dash equal to R1 dash plus R2 dash, that is two number of releases to be deducted. We will continue further. I already told, if it is a one hinge connected with two members, one release is possible. Two hinges connected with each two members. First one, for one hinge, one release is possible. For the next hinge, another one release is possible. With this understanding, for this cantilever beam, totally three number of unknown reactions and moments are possible. So 3. Number of available equations 3. So the external indeterminacy equal to 0. What is meant by internal indeterminacy? 3 number of closing loops minus releases. So there is no any other release. So there is no closed loop. So it becomes 0. Finally, the total static indeterminacy is equal to 0. Hence, it is stable and determinate structure. We can conclude as a stable and determinate structure. This structure U minus E, so one vertical and two unknown reactions. So totally 2, 3, 4, 5, 6 and 7. So 7 unknowns minus 3 equations. So 4 static external indeterminacy minus 3C. There is no any closed loop. So 3 into 0 minus the releases. How many number of releases? Only one release is possible. So it is minus 1. Static external plus internal indeterminacy equal to 4 minus 1 equal to 3. The internal hinge is the part of internal indeterminacy. So this structure is stable and indeterminate structure. You can see the total static external indeterminacy is 4. While introducing an internal hinge, some releases is possible, hence the structure becomes lesser indeterminate of 3. So if you introduce some hinge at the intermediate point, you can make the structure lesser indeterminate or purely determinate. If you introduce another 3 hinges in this structure, you can make 3 releases, hence this structure will become 0 indeterminacy. So for this structure, how many number of reactions? One vertical, 2 unknown reactions. Here 2. So 2, 4, 5, 6 unknown reactions minus 3 equilibrium equations. Totally 3 external static indeterminacy. Internal static indeterminacy is 3 into C. There is no closed loop. So 3 into 0 minus ultimately 2 releases possible. For this hinge connected with the 2 member, it is M minus 1 equal to 1. This hinge connected with the 2 member, M minus 1 equal to 1. So 2 release is possible. So you can deduct minus 2. So external indeterminacy deducting internal indeterminacy will become 1 indeterminate. This structure 1 determinate. Next one. So we are going to identify the unknown reactions. For all the structure, mark unknown reactions. I think you can able to understand this internal elements. This is horizontal roller release. It is not a support condition, it is a roller release. We already studied in the previous video lectures. Okay, I am going to display the answers. Okay, U minus E. So 3, 3, 6. Here 1, 7 unknown minus 3 equations. So 4 number of external indeterminacy. So internal indeterminacy 3 into number of closed loop 0 minus the internal hinge is provided for this 2 members. So 1 release is possible. For internal hinge is between 2 members. So here 1 release is possible. Totally minus 2. 4 minus 2 equal to 2. Hence stable and determinate structure. Here it is a horizontal roller release. So totally 6 number of unknowns, 3 number of equations, 3 no closed loop. Only 1 displacement is allowed here. If there is a roller at this point, it will move towards this direction. This bottom will move towards this direction. So anyhow, this horizontal displacement is possible. So it is only 1 release is allowed. So 3 minus 1 equal to 2. In this also a horizontal roller is given, horizontal displacement as well as vertical reaction. Both are released. So 6 minus 3, 3 minus 2 is the release. 3 minus 2 equal to 1. So in this an internal hinge is present. So 1 release is possible. Here it is a roller condition. So here 3 number of unknowns should be counted. Here 3, here 3. So all the known parameters should be mentioned so that it will be easy for the next step. Let us have a glance. 10, 3, 6, 9. Sorry, 3, 6, 9 and 1 vertical reaction. So totally 10 number of unknowns. minus 3 equation, totally 7. So this is a support condition. There is no release for this. If it is a release, then the member should be specified like this. Both the members are separated with the roller, then only we can count for release. Otherwise it is a support condition from this member to this member, so then only it is counted for reaction. So 3C minus R dash is the release, only one release is possible due to this hinge. So 7 minus 1 6, stable determinate structure. Here U minus E, 4 minus 3, actually 4 minus 3, there is no closed loop in this problem. Here it is 1 2 3 4 number of closed loops, and one hinge is available with the connecting two members, so R dash equal to 1. 3 into 4 minus 1, 12 minus 1, 11, 12 minus 1, 11. So static internal indeterminacy is 11, indeterminacy is caused. Actually it is a roller condition, it will move towards horizontal, so there will be a release here. It is not 4, it is 3 minus 3 equal to 0. So the 11 number of static indeterminacy is available, because 3 number of unknown reactions only present. Here mistakenly it is typed as 4. Next problem, you kindly note down these problems for your homework. I just pass on to the next. You understand and you copy this in your notebook, and if you have any doubt you can discuss in the class. So this is basically to understand the space structure. 3 number of forces in 3 direction, Fy, Fx and Fz, and 3 number of rotations in the corresponding 3 directions, My, Mz. That's why we included 6J and 6M like this. So these are the 3-dimensional structures. So here we have 3 directions, and each direction will have each moment. So one support will have 6 number of unknowns, both the supports will have 12 number of unknowns, and also available equilibrium equation we have 6. How? Fx, Fy and Fz equal to 0. Similarly Mx, My, Mz equal to 0. So 6 number of equations, and one closed loop is present here. So 6 into 1, so 6. So 6 minus 6, 6 plus 6 equal to totally 12 degrees of freedom. Here also it is 6, 12. Here 3, there will be 3. Here 3, 3, 6, sorry, here 6, 6, 12, 15, and here only one vertical reaction is possible. There is no moment here, bending moment is 0 in both the cases. So totally 12 plus 3, 15, and plus 1, 16 minus 6 equal to 10. And internal indeterminacy, one closed loop is available here, minus we have to multiply for the space frame. Normally M minus 1 releases is possible in 2-dimensional. For the 3-dimensional you have to multiply with the 3 into M minus 1. Only one hinge is presented and connected with the 2 members. So minus 3 into 2 minus 1. So minus 3. So 6 minus 3 equal to 3. So 10 plus 3 is 30. You try these additional problems with the available answers. Copy these problems in your notebook. So next one, kinematic indeterminacy. Before going to the topic, what is meant by kinematic indeterminacy, you definitely remember this term, that is degrees of freedom. What are the freedom allowed in a particular point? The freedom is in terms of deflection and slope, otherwise y and theta. So for example, if you consider this support, the displacement in x direction as well as y direction is not allowed. In this support, the displacement in x direction is allowed but y direction is restricted. In this support, the displacement in x direction is allowed, y direction is restricted. Similarly, you have to understand the reactional component. At the fixed support, there is no degrees of freedom. It is 0. Okay. You mention this and can. So it is 3j minus r plus release. R dash is the release component. So 3j, number of joint 1, 2, 3, and here is 4. So 3 into 4 minus the reactions, 4 reactions, plus releases, there is no release, totally 8. And you consider the kinematic indeterminacy neglecting the axial deformation. It is a one member, this is another member, this is another member. This member will have its axial deformation. That is also considered in this answer. The axial deformation is also considered in this answer through this formula. By neglecting the axial deformation, we can deduct the number of members. So 8 minus 3 equal to 5. Here next problem, 3j minus r plus r dash. So 1, 2, 3, 4, 5. You consider the internal hinge also and joint in kinematic indeterminacy, because it is a point where the degrees of freedom can be considered. So 3 into 5 minus the reactions, 3, 4, 5 reactions, plus 2 here releases is possible, because one hinge connected with this 2 member will have one release, here one release. So the releases to be added in kinematic indeterminacy, whereas the releases to be deducted in the static indeterminacy. So totally 12 number of kinematic indeterminacy. Then neglecting the axial deformation, 12 minus 4 members. 1, 2, 3, 4 members. So it is 8. So next one, it is 3j minus r, same formula. 1, 2, 3, 4 joints. Reactions 3, 4, 5, 6, 7 reactions. There is no releases, so it is 5. And neglecting the axial deformation, we can write here 5 minus 1, 2, 3 equal to 2. You can try these problems. So there's available answers, and you copy down on the notebook. So this is a truss member. So we specified as 2j minus r plus r dash, because each joint is having only the forces, there is no moment. That's why up to the previous problem we consider 3j, because one moment is also considered in a portal frame or in a beam member. Here it is a frame member, it is a truss member, so it is 2 times of j is only considered. So number of joints 3, 4, 5, 6, 7 joints, minus reactions, one vertical, because these are roller support, there is no horizontal restriction. So 2, 4, 5, 6, 2, 3, 4, 5 reactions. and there is no releases, so it is 9. Here, neglecting the axial deformation, it is already neglected because it is a truss member. The axial deformation is neglected from its basic assumption, so there is no need of calculating decay and neglecting the